All right, does anybody remember, you know, when you look at the form of a line like this, does anybody remember anything about it? Anything at all?
Rise over.
Ah, awesome. Let's start there. So, when we're talking about slope, this is super important. Whoops. Rise over run. So does anybody, can you explain what does it mean, rise over run? Rise before you run. Okay, that's not a bad way to remember it, I guess.
Up and down divided by the...
Yeah, it's going to tell us how we move along the graph, right? Tell us how many to go up and how many to go over. So we'll practice that in just a second. Do you remember anything else about that form of a line? B is something is correct. Does anybody remember what the B is? Yeah, that's right. So B is the Y-intercept.
I have no idea what that means.
And what that means is it's where it touches the Y-axis. Okay, so if we use what we've just recapped and we wanted to graph a line y equals 2x minus 5, there's nothing wrong with you just throwing away all those shortcuts and going like this. Always a good idea to remember, go back to basics when you forget. I mean, no matter what we're graphing, you can always plot points to help you figure it out. So for example, when x equals, let's say, 1, can someone give me a value for y?
4. Wrong.
Yeah, it's going to be negative 3. If I put in x equals 1, then I get negative 3. So there's one pair. I could also go 1 over, 3 down. Right? How many points do you need to know where the line is drawn? 2. So if anything worse comes to worse, you only have to do this twice and you could still figure out what the graph looks like. So someone, let's see here. What if x equals 2? Yeah, it's going to be negative 1 this time.
Start all over because Tim's confused.
Okay, I'm going to just give me a second to zoom in on that graph just so you can see it a bit better. All right, so that is one possibility. Let's take a look at how it connects back to the shortcuts. When x equals 0, what's the value for y? Yeah, because then it would be here, it would be 2 times 0, which means that whole thing disappears, and you just end up with negative 5. So at 0, we'd be negative 5. So that's the y-intercept. If we're trying to review to you what those pieces were, that right there touches the y-axis, and I usually abbreviate it like this, y-int. Okay. Now, rise over run. How do you do this again with rise over run? So slope here has a value of what? 2 over 1, or just 2. So if it helps, you can think about it this way. Which means what in terms of rise over run? Rise is 2, moves over 1. So let's see what would happen if I go up 2 and over 1. Oh, look at that. I just landed on one of the points I was supposed to have. If I go up 2 and over 1, I still land on that point. So you can keep doing this as many times as you want to get more points on that line, right? So every time you go 1 over here, that means you end up going 2 higher here, right? So this is what the line's going to look like then if we put all that together. And, you know, I'm always the first guy to admit my artistic skills are pretty bad, but
That's pretty good. That's actually really good.
that may be the best line I've ever drawn.
Good job.
But anyways, if I'm looking at your graphs, as long as I can clearly see 2 points that show it's on the line, then that's fine. If it veers off a little bit, that's okay. But
Indicate which is rise over run.
which is rise over run?
No, do we have to indicate which one is?
You do not have to write down specifically rise over run, but it might be helpful for you as you're practicing, okay? But in this case, if you do, you could put in the margin rise equals 2, run equals 1. All right, so let's talk about the next one. Did anybody need time to draw a graph for their notes? All right, I'll give you a minute. So tell me what you know about this equation, negative 3 over 2x plus 5. What do you know about this one?
There's a fraction.
There's a fraction. Does that scare you?
3 over 2.
Everybody hates fractions, but in this case, fractions are kind of easier. Why might they be easier?
Because it already says the rise over run.
You can see the rise and run right in that picture, right? So even though there's a fraction there, this one tells me that what I'm going to do is I'm going to rise negative 3 and run 2. What does it mean then if I rise negative 3?
You're going down.
Good, you're falling then, right? You're going down. Okay, what else can you tell me by looking at that equation? The intercept's at 5. So to do this with the shortcut, I could go y-intercept is 5, and I'm going to go down 3 and then over 2. Down 3 and over 2. Here's a tip for you. If you, hang on, sorry, lost my train of thought. If you're going to do your graphs, try doing 3 dots. How come you'd want to do 3? Well, let's just say, for example, you went like this by mistake, and then you went and put another dot. Let's see here. Well, you're going to notice that your line didn't line up, so you probably made a mistake somewhere. Okay, so just it's.
You start at 5, I get it.
Yeah, but anyways, it's one quick way that could possibly give you some security in your answer. So it doesn't take that long.
It's always the top that has the negative.
Yeah, it doesn't have to be that way, but that's the easiest way most people do.
So the bottom one can be negative also?
It can be negative values.
All right, just because it's come up, normally students, are happy with just one way, and that's fine. But we could also, I'll do it in a different color, but it's going to give me the same graph. If I went rise by 3 and run by negative 2, what do you think it means if you run negative 2?
You go backwards.
You go backwards. So if I obey the same rule, this one would say go up by 1, 2, 3, but then go backwards by 2. It's the same line, so it's okay whether you decide to make the top or bottom negative, but don't make them both negative. There's only one negative sign there, okay? So this line then, I could draw fairly quickly, should look about like this.
Damn, girl.
You're really good at your lines today.
Thanks, I'm on fire.
You're the guy on fire.
You know,
He doesn't get it.
I do, I've seen the movie.
Oh.
Yeah, hey, when you're a math teacher, life doesn't get any better than straight lines, hey?
Everybody loves it.
And of course,
It's a skill.
if nothing else, you could throw in x and y points too, right? So, you might say to yourself, put in x equals 0, y equals 5. You have to pick good ones or you're going to get fractions. What would be another good one if I was picking? I would pick a 2 because then those would disappear, right? You're going to divide by 2, multiply by 2. Whatever's on the bottom of that fraction, that would be a smart one to pick for x. So anyways, if it was at 2, then I would be at positive 2 here.
How do you do that?
Okay, can anybody tell me what would be another good point to pick? 4 would be another good point to pick. There's nothing wrong with picking 3. You're just going to have a fraction if you pick 3. Because if I put 3 into here, it would be negative 3 halves times 3 plus 5. So I'd get negative 9 halves plus 5. And now you have fractions to deal with, which is fine. But just realize that if you pick a little more strategically, you can avoid them. 4 is a better choice because if I pick 4, that fraction is going to go away. because then I end up with negative 12 over 2, which is also known as negative 6. So 4 would be a good choice, and I would get negative 1. And that's the point right there. Now, again, you don't need to stick to any one way. I just want you to have some flexibility. So far, we've talked about using the intercept and the slope. This is using a table of points. Okay? So there's one other way that in grade 10 you would have encountered for graphing, and that's when you have equations that look like this. Okay? So there's, let me go through a couple ways of doing this. There's some we can rearrange, but sometimes we can also make things a bit easier too, and that's to do this thing called the intercept method. So let me show you what the intercept method is. So when you're, I'll be honest with you, I'm going to give you a little secret about math. Even mathematicians really hate math because nobody likes doing all those calculations by hand, and good mathematicians are always ridiculously lazy. So I'm ridiculously lazy too. If I make mistakes when I'm teaching math, it's because I'm trying to skip things because I'm being lazy. So when you want to be strategic, you usually want to be lazy about it. And the best way to be lazy when you're doing this kind of problem is to use zeros. Because when you use a 0, that means something disappears, right? 3 times 0 is 0. So now I only have this one letter left. I have to figure out what value of y would make this happen. So if 2y minus 6 equals 0, then 2y equals 6, y equals 3. So now I've got 1 point out of it, and I only need 2 to graph the line. I'm going to do this one again. I'm going to be lazy this time. I'm going to make y disappear this time, which means now my equation looks like this. It goes 2y is going to be gone, and I have 3x minus 6 equals 0. So 3x equals 6, x equals 2. So without having to do all that rearranging, I have 2 points now that I can graph this line. So that'll be 0, 3, which looks like this, and 2, 0. So there's 2 points that could get me started. Oh, that line has a bump in it. It's just ruined my day. But that would be, anyways, one way we could find this line. Okay, I'm also going to show you how we could do it by rearranging, because that's something we'll have to practice as well. So I'll do that in purple. If I had 3x plus 2y minus 6 equals 0, normally when you look at a graph, the way you like it is when it says y equals. So you want to do that in this case. You want y to stay on one side and everybody else to be moved over. So what I'm going to do is move everybody except y to the other side. Okay. Then what I'm going to do is, I don't want to see it as 2 y's. I just want y all by itself. So how do I get y all by itself now? Yeah, good. So if I divide everybody by 2, this is what I'm left with. This is what we just practiced. So here's my y-intercept at 3, and there it is. If I follow this, it says fall 3 and move 2 to the right. 1, 2, 3 down, 1, 2 over. So we found the same equation, right? So there's a couple strategies for you to try. With the next one, I want you to try both, okay? I'm going to pause here, see if you can try doing both ways. One is to stick in zeros. The other one is to rearrange. I want you to try both so that you can make the decision on your own when you have to do your homework or tests or quizzes and that sort of thing, okay? So for now, you have to do both. Okay, so first of all, I'm going to go through the intercept method, which is, this is the method where I'm going to plug in my favorite lazy numbers that knocks things out. So I'm going to have, if I knock this one out, I'd have 6y plus 18 is 0. So 6y's equal negative 18. Y equals negative 3. Now, if I plug in 0 for y, 2x plus 18 equals 0. That means 2x's is negative 18. So I get negative 9. So there's 2 points. That's enough now to graph the line. So I can trace that through. But before I do, I want to go through the final method, which is really the last way we're going to do this is the most versatile way, because you'll see later that we may have problems with shortcutting. But when the shortcuts work, they're certainly nice. So if I have, say, does blue show up okay for everyone? I'm running out of space, though. I'll do it here. So if I have 2x plus 6y plus 18 is equal to 0, to rearrange this equation, I'd like it to be y equals something. So everybody but y moves to the other side.
Is it always y?
Yeah, we always want it in terms of y as our, x is our independent variable, y is our dependent, so you want it to be y equals. So whatever's dependent stays on this side. So then I have to get rid of that 6, so if I divide everyone by 6, so this is the equation that I'm left with, negative 1/3 x minus 3. So here's the y-intercept at negative 3, and this says fall 1 and move over 3, right? Or those of you who saw it the other way, remember you could also go up 1 but backwards 3. And if I go up 1 and backwards 3, look at that, I land on the same spot. So same line, 2 ways of finding it. I'm back. Okay. Any questions there? Can I just see how many people were able to do the, I'm not necessarily saying that you got both of them, but how many of you were able to graph those, that example there? You're able to do the graph. Oh, genius. Okay, we can move on then, right?
And your straight line.
All right. So I want you guys to talk this one out with your partner, see if you can graph it. Any method you choose. Anything we've talked about so far? What do you think about this equation? Can you do it? All right, let's see what happens. If we try to do the shortcut method and we go like this and we say, okay, here's x and y. I'm just going to put in my zeros. If I put in y equals 0, I actually end up with a bit of a problem, because 5x plus 9 equals 0. That means it's not that I can't solve this. It's that 9 over 5 is hard to find in the graph paper, right? So it's not the most ideal way to do this problem. Does it work? Yes. But is it very convenient? No.
How would you find it from there?
So, oh, sorry. It's a negative. Thank you.
Oh, I thought I got that wrong.
Let me just move them over, and then it'll be like it never happened. Oh. Ah, stop it. It doesn't want me to cheat, I guess. Okay.
Just draw a negative.
Yeah, I think I'm just going to have to put the negative, sneak a negative in there. Okay, so if it's not that convenient, we can still work it out, but let's work it out with the rearranging. So I have 5x plus 3, y plus 9 equals 0. So 3y is negative 5x plus 9.
Negative 9.
Thank you. I'm feeling awfully positive today, I guess.
Oh my god. Oh my god.
Okay. So in this form, that fraction's okay. Remember, that fraction just tells me the rise and run. 5 over 3. I divided everybody by 3. No, I've already done the division up there. So this one says at negative 3, and I'm going to drop 5 and move over 3. Okay, and if I wanted to go the other way, I'd go up 5 and over 3. Backwards by 3. So up 5 and over 3. I know. I got nervous because everybody expects perfection now. Okay, so again, let's look at this one. Can you predict, is this going to be a good one for the shortcut? How come it won't be good for the shortcut? Yeah, because if you just quickly go like this and ask yourself, is that easy? Yeah, 5 and 10, they both have whole numbers. But 3 and 10 don't, right? 3 and 10 is going to be a fraction. So it's probably better that I don't go with the shortcut here. So try rearranging this to graph it. All right, let's 5y is negative 3x. So y equals negative 3 over 5x minus 2. So I drop 3 and I move over 5. Drop 3, move over 5. Yeah, question? Sorry? Did I drop the wrong amount? Nope, 3 is okay. That's.
So you always leave y on the left side?
Yeah, you want your, no matter what you're doing, this is the most convenient. This way is also very convenient for finding points in the table too, right? Because then you put in an x, it gives you a y. All right, so let's finish this one off here. If I backed up, it would be like this. Oh. Let's see if I can get it.
You're getting really good at it. You're amazing today.
Nah, there's still a bend in the top, but anyway. I appreciate the encouragement. Okay, so we're going to move down then. Does anybody need that slide for a minute? I'm terrible at circles. Circles are awful. You know what the problem with circles is? Is the slower and more you think about them, the worse they get. Try it. If you draw it really fast, you'll draw a better circle than if you draw one slow.
Do it right now, do it right now.
There's a draw circle contest.
Anyways, too much pressure, too much pressure.
There's actually no, there's a contest for like people.
All right, so there's this other little weird thing. Thank you. I love my shushers. There's this other little weird thing you might have forgotten about since last year, and that's what happens if you just have a single, like y equals 3. Does anybody remember what happens?
Over 1. Nope.
Well, what you want to remember is this equation describes something. It describes the value of y. So if I say x equals 2, what do you think the value of y is going to be in that equation?
What? 0. 2.
Wow, classic overthinkers.
Positive 2.
Negative 7.
Negative 2.
Okay, hang on. X equals 5. What's the value of y?
3.
Oh, good, good. Okay, x equals 30. Y equals?
3.
X equals 1,000,000,000,000. Y equals?
3.
Every possible value of y is 3. So how do we show that in a graph?
That's right.
Every possible, and I'm not talking properly either, but every possible value of y is 3. Okay, so if I wanted to show you this equation, it's going to be all values of y are negative 7. So I drop down here. And can anybody figure out what will it look like then if I tell you x equals 5?
Up and down?
You guys are Braves fans, hey?
Yeah.
The tomahawk? No, it's vertical. It's up and down. So at 5,
Use yellow.
I'll use yellow next then. That's the line x equals 5. And for the last one at x equals negative 2, again, that is saying every value of x is negative 2. So here's a graph where every value of x is negative 2.
So bright.
Stacked.
Good color choice.
Yeah.
The green is pretty too.
So then, what about it?
What about?
I see the green.
So we're talking about all possible lines. Right now you can do any line on a tilt. These are the vertical and horizontal lines. Okay, so now you can do any possible line on there. You can do any one on a tilt, and you can do vertical and horizontal as well. Okay. So the last thing, I'm going to have to zoom out here. No, these ones, what do you mean I didn't draw them? Of course I did, look. There is no line tool on this.
Your lines look more natural.
So what I'm going to leave you with here for us to conclude on, I want you to match up these equations. So how you're going to do that? You got to think, how do I find a point that matches this equation? What is the intercept? What is the slope? Match up the properties on them. You're going to take, let's say, the next 5 minutes or so to work on those, and then we'll recap together. So strategy-wise, yes, some of you have noticed that they all have the same y-intercept, right? So we're not stuck, though. We can still figure out other ways of deciding what these lines are going to be. So, for example, how else might we distinguish them? They're rise over run. So some of them are going up, some of them are going down, meaning some of them are positive, some of them are negative, some of them are steeper than others. That's all going to be a clue for us. But before I can do that, I need a convenient way to look at them. So let me call this, and I'm going to have to get out a yellow there. It's too bright. So graph number 1 is y equals negative x plus 3. Graph number 2, if I rearrange that one, I could go like that. Does that freak you out if I put the y on the other side?
Yes.
Okay. All right. That one is, okay, negative y and then negative 2x minus 3, so y.
We can make all of them positive instead. Oh, there we go.
Anyways, we all have it, but there you go. 2x plus 3 should be the correct one once we rearrange. For graph number 3, we're going to have negative 2y plus 6, let's move it to the other side, equals negative x minus 6. So then when I divide everybody by 2, I get y equals negative, positive.
1 over 1. No, 2.
How do you make it positive?
Well, a negative divided by a negative gets you back to a positive, right? So when I divide everybody by negative 2, it'll change their sign. Oh, and sorry. Yeah, this one should have been a y. It was typed in there wrong. So for number 4, 3y equals negative x plus 9. So y equals negative x plus, excuse me. Let's see here. Did I do that right?
It would be negative x, 3x.
Oh, right. Thank you. Thought I was missing something. All right. So here's the way we walk through these equations then, if that's what we're looking at. We already said they have the same y-intercept. So let's talk about slopes instead. Do you see one up here that has a slope of negative 1?
The third one.
So you could tell me like top right, bottom right, top left, bottom right. Well, bottom right, 1 down, 1 over.
It should be 1.
1 down, 1 over, that's negative. Because remember, when the slope is negative, it's falling, and this one is dropping. So we should be thinking about the graphs on the right side. The one with a slope of negative 1 is this one here. So that's equation number 1. Okay, this one here has a slope of positive 2. So if the slope is positive, what's it doing? It's going up. So which of those graphs do you think could be going up with a slope of 2? Bottom left, yeah. See this one here, it goes up 2 and over 1. So this is equation number 2. Okay, and then this one here, the slope is a half.
First one.
Yeah, so it's going to be this top one. It goes up 1 over 2. And that leaves us the last one here as number 4, but we can verify that if the slope is negative 1/3, that means I fall 1 and move over 3. Okay, so that's how they match up.